describe a system, describe a mass moving mass, a spherical mass, spherical ball is rolling on non-slippery inclined plane. Okay. If spherical mass is if spherical ball is rolling on the non-slippery inclined okay, plane. Okay, so what will be the solution? Well, now I have already explained it many and many times. If this is a two dimension and this is the plane, okay, so this is the plane, inclined plane, and if this is a sphere, okay, and if that distance is delta s, okay, okay, this is total length is L, okay, total length is L, if this angle is phi, okay, okay, you may say that that is L, okay, you are right. Why I am writing this, I may say that that is delta L, okay, okay, and R is the radius of the ball, theta is, this is delta theta, okay, yes, yes, if it has covered the distance delta L, this distance will be L minus delta L. L minus delta L. Okay. And okay, so for this system, you have constraint. What kind of the constraints you have? Constraint. What are the constraints you are applying on this? Because it is a rolling ball, so that will be followed that delta L will be equal to R delta theta. Okay, you must know how this equation is coming. Actually, mostly students draw the very wrong picture. Okay, so try to understand the concept of this picture. Okay, why this delta L is equal to R? Because this is the displacement delta theta. This arc length will be equal to this displacement. That's why that delta S mean actually this is delta S, and this delta S will be equal to del L, because when it roll it will be covered this distance. Okay, that's why this is equal. You must mention each and everything in the exam. Okay, but in the midterm exam, I'm very disappointed. Even your toppers. Okay, so you must explain. Yes. Yes. नहीं कितना पेज इतना ही ऐसे ही ना mention करो. You must. I'm not saying that you must write all the stories, but you have to mention. You have to describe that you are familiar with that. You know that what is going on that, because you must to present yourself. You know all the reasons. Okay? As this picture is explaining that this equal to this and this equal to this, at least you can draw this picture. correctly. Okay, so explain. You must the reflection should be observable at your paper, that you know each and everything and reasons and justifications etc. Okay. So because this delta L equal to this delta L equal to delta S, so this dl become R delta theta. Actually, this is the R delta theta. Okay. So change is, there is two type of the two variables. One is L and one is a theta. Okay. So because it is changing with respect to passage of time, so you will R is constant, so it will come out from the this, and when you take the limit that approach to delta t approach to 0, then that will be L dot will be equal to R theta dot. This will be constant. Okay. And your constant equation will become this implies that L dot minus R theta dot, that will be equal to 0. That will actually the weakly 0. Okay. Because this is itself 0, but it's the partial derivative is not 0, so that's why according to in a Dirac definition, not my definition. Okay, so that credit goes to Dirac. Okay, and so I will not interested to take the credit of Dirac. Okay, so Dirac is defined as weakly 0, and for reference you may study the introduction to quantum mechanics, the lectures of Dirac in I think Cambridge, I don't know remember, but the Dirac lectures volume 1, okay, in quantum mechanics. Okay, so this phi will become, this constant is phi, and this will be x dot, sorry, this is L dot theta dot, that is L dot minus R theta dot, that is weakly equal to 0. Okay, yes. Okay, so when this will be equal to this, what will be the your L? Now you have to find L. L is kinetic energy minus potential energy. Okay, so L is equal to kinetic energy minus phi. Okay, V. Okay, potential. Kinetic energy, what will be the kinetic energy? What will be the kinetic energy? Kinetic energy of center of mass plus kinetic energy with respect to center of mass minus potential. Okay. Minus potential is x. Okay. Okay. Now the question is, what is the potential? Potential क्या होगा इसका? दो dimension में नहीं होगा. Okay. Yes, that will be a 2 dimension. Okay. Yes, because it is in xy plane. You are right. Okay. In 1 minute, please. Firstly, I have to mention, then I will repeat. Okay. Okay. So what will be the potential? Potential क्या होगा? What is the, firstly we write the kinetic energy. What will be the kinetic energy? The kinetic energy is 2 dimension. The kinetic energy, you are right. The actually QK is there is 2Q1 and Q2Q, because it is 2 dimensional plane. You are right, and that will be here. That will be R and sorry. L and theta always come. I have already in a polar coordinate, that will be L R theta dot. Okay, so sorry, theta dot. Yes, you are L and theta. Okay, L and theta. Yes. But in constant R theta. Yes, you are right. Okay, the L and theta. Okay. Okay. Kinetic energy will be. Then I have already explained that kinetic energy is 1/2 m r dot square, 1/2 m dot r theta dot square. Okay, I have already explained in the previous exercise. That will be the kinetic energy. Okay, this is the kinetic energy. Okay. I have already explained in the polar coordinate form. Okay? In two-dimensional plane. Okay. This is the kinetic energy. Okay. And now the question is, what will be the potential energy? It is has proved in the mass moving in a plane in the previous lectures. I am explaining that I have proved that the kinetic energy will be two part in two dimension, that will be r dot square and r theta dot square. That is the question, mass moving in a two dimension plane, okay, in polar coordinate form. Yes, this lecture is available, okay. If you are interested, I will be shared it on your group, okay. Okay, what will be the potential? Potential क्या होगा? Potential is potential energy. Potential energy. मतलब this is a potential energy. What will be the potential energy? So what will be the potential? Yes, mgh. Potential energy is mgh. You are right. M naught gh. Okay. Okay. No. This will be mgh. Okay. This will be parallel. Okay. From center. Okay. Yes. And that will be equal to, h will be equal to, no, L minus R phi, that will be, okay, अच्छा ठीक है, आपको बड़ी परेशानी उनकी, L minus delta L, okay, this L minus delta L, and this is phi, okay, and this will be, what will be this? L minus delta L sine phi, okay, H will be equal to this. This will be H, okay. So M naught G L minus delta L, okay, that the actually length is this, okay, and the L minus, this will be sine phi, not theta. This is different and this is different. You must keep in mind. This is phi, not sine theta. Okay. So this phi is constant with respect to theta. Okay. Okay. So this will be potential. So Lagrangian will become. So L will become. What will be L? 1/2 m naught r dot square plus r theta dot square. Okay. Okay. Minus m naught G L minus delta L sine phi dot. Okay, so this will be your Lagrangian. Okay, now this will be this is a semi-holonomic constant. Semi-holonomic constant. This is the semi-holonomic constant, and that will be the equation of the Lagrangian. Okay, when you will combine both, okay, so you will get you have to write the there's actually this is starting mistake. Okay, so there's no. typing mistake is a very important in the lectures because it's always help you to catch your attention. This is a figure which is explaining our problem that the rolling of the ball on an inclined plane, which is the non-slippery. Okay. So this is theta, this is delta S, and because this delta S will be equal to this delta L, because this change in arc length will be equal to this displacement. So delta L will be equal to delta S, that will be equal to R delta theta. Okay, so so this delta L, because this delta L equal to this arc length, and arc length is R delta theta. Okay, and when we, so this will become equal, R is constant, so when we apply the limit delta t approach to 0, okay, then when delta t approach to 0, R will be constant, so it will come out from this change because R will be constant with respect to time. Okay, radius is the constant. Okay. So you will get this expression, and this will make the semi-holonomic constraint because this constraint is depending upon the time derivative. When the time derivative is involved or velocity involved, then that type of the constraint will be defined as a semi-holonomic constraint. So this will be a semi-holonomic constraint. And so Lagrangian multiplier method. So there will be no good coordinate. If in exam I ask, is there any good coordinate for this system? There is no good coordinate for this system because the coordinate will be depending upon each other, not independent from each other. Okay, so it means the constraint forces will be exist. Okay, so this will be the potential energy as I have already explained. Okay, so this will be the we have already find this expression for the kinetic energy. This is the expression for the potential energy. So this will be kinetic energy minus potential. We will take the kinetic energy minus potential energy as a Lagrangian, and this will be the semi-holonomic constant. Okay. Okay. So what is the equation for Lagrangian multiplier method? You know that that will be equal to d by dt. There are two methods. You may write a d by dt or a virtual displacement form. Okay, so that will be equal to partial L over partial Q. No, not. Sorry, QK. Actually, I was because I worked on the. I always work on a relativistic Lagrangian, so that's why I was writing to as a column, but it is not the part of your course because you belong to the undergraduate level and there is no relativistic motion is involved. Okay, so that's why I must write the K. That's not a K, I think. Okay, firstly RK, okay, minus partial L over partial RK. Yes. Yes, there is dot. Okay. Minus plus d by dt partial Cm. And number of constant is 1, so I may directly write C. I must write the Cm, but because number of constant is 1, so that's why I will write only the C. Have you got it? Okay, so. हाँ, it's up to you. C को किसी भी चीज से represent करो, lambda से कर दो, C से कर दो. That's up to you. ठीक है? That is constant. That is not constant. That is variable with respect to time. Mean that is the function of time, but that is the constant with respect to position and velocity. Okay. So that's why that will become out from the. So that will be d by dt. You may replace C with any other constant, lambda, C, whatever you are interested. Okay. So. If you have the first alphabetic as your beloved, then you may write. Okay? Examiner will be not confused with that. Okay? He must not have any problem with your alphabetic. Okay? So phi is constraint. This phi is not a potential. This is constant. Okay? And that is the equation 2. This is phi. Okay? And this will be. Okay. There is plus. Okay. That will be the Cm dot, okay, time derivative, and I think partial, total, partial, R dot K. That was, I think, equation. Okay, that is equal to 0. So this was the actually, okay. So okay, have you got it? Okay, that is the equation we have already derived. And when we put all these values, when we take the partial derivative, actually this is R is, okay, no, sorry, I am wrong. This R is different. This R is the, this R, always remember, important to note, either important to note, that may be confused in your, confused in exam. That's why I usually prefer to write Q, because it's not mixed with the other. This is, this R is not the, this RK is not equal to this R, because it is coordinates, okay, position coordinates you make a coordinates are variables, okay, and this R is, what is this R? This is the radius, okay, so you must not confuse it. This is a radius of spherical ball. You must remember this difference, okay, so that are the difference, okay, okay, and from the constraint you may also observe, easily observe, that RK has two value. RK is not one, RK has a two value, that is R1 and R2, okay, and R1 is L and R2 is theta. That all the changing occur due to two things: L, displacement, and theta, angular displacement. Okay. So the changing are occurred due to the two variables. That one is the L and one is the theta. And you can also observe it from the changing from this constraint equation. That is, this constraint is function of velocity of L and theta dot. Okay, not phi. And also remember that theta is not equal to phi. Okay, so you must know the difference. That is not equal. What is the difference? Theta is the angular displacement, and phi is the angle of inclined plane. Okay, so you must note it. This is angular displacement, and what is this? Angle, fixed angle. This is a fixed. This is a variable, but this is a fixed angular angle of inclined plane. So that is the difference between these two angles. Okay, these are the common mistakes occurred in the exams. Okay, so that's why I want to clarify that this R is not equal to this, and this is not equal to this. This R is the coordinate, and this R is the radius. That is also fixed. Okay, that is variable, and this is fixed. Radius is constant. Okay. Similarly, angular velocity, angular displacement is not a fixed. Okay, that is the variable, and but this is the fixed. Fixed means constant. Okay. That is not changing with the passage of time. Passage of time. Okay. So there are two variables, L and theta. Okay. So firstly, as we have already done in the many times, firstly we will consider the R1, that is L. Okay. Firstly, we will solve. For this. Okay. RK की जगह L आ गया. Okay. So take with derivative with respect to. Okay. So from this equation, derivative of L is this with respect to L. Is any here L? No, there is no L. Okay. So this term will be 0. Partial derivative of L with respect to, sorry, Lagrangian with respect to L will be 0. Okay. Here L is will be fixed. This L will be fixed. Okay. And this is variable. Okay. So you must remember. If you want to change this delta L with the, there are two ways. Okay. In my in some lectures I write it as a delta S. If you want to interested writing it as a S, you may write as a S. Okay, and if you are interested to write it in the form of L, then this will be a, actually this is changing displacement delta L, and this total L is the fixed. So if you are differentiate between the L and you may write if you are not interested to write L, then you may replace this L as a S. Okay, and this delta L with the S. You may replace with the S dot, and this is S. Okay, but if you are not interested, even then it is okay. You must know that this L is fixed, that is variable. Okay, this L is total length, and the remaining is this. Okay, so that's up to you. Okay, if you want to replace with the S dot S, you may watch my previous lecture. And if you are interested in because this is a new class, new lecture, so that variable must be new. Okay, so if you are interested to write it, this is delta L. Okay, then this lecture is available. So that's all up to you. Okay, okay. So if R1 is L and you take the derivative, that will be 0 because here no L is involved. Okay, so derivative will be 0. Here this delta L means delta L. Okay, this L is constant, and this what will be what must be answers? Okay, so minus mg is constant. Okay. So minus negative m naught and g is constant. When you take derivative of L with respect to L, delta L with respect to delta L, that will be a 1. 1. Sin phi is constant. Phi is constant here. The derivative of sin phi. Derivative of sin phi is not cos phi. That will be constant with respect to derivative of L and T, because phi is fixed. Here phi is fixed. I have already mentioned phi is fixed. That means that their derivative is 0. So mg minus mg sin phi, that is the constant. Derivative of delta L partial L with respect to, no, that's wrong. Even no delta L is involved. There is no delta L. So all this term will be 0. Okay. The derivative of 0 is 0. Okay. This is minus plus. Okay. Now the term this is done. Okay. And we take the derivative with respect to L minus m. Minus plus, this will become a plus, but when we take the minus, then that will become a plus. So if you are interested, I love to write it in this way, delta L minus L, and that becomes, because it not create a problem. What is the minus L?
The problem creates minus, whole value is minus with L.
I have taken the common, minus multiplied by minus will be minus, minus multiplied plus will be minus, and this become a plus. Okay, so that's why I have taken the common, minus as a common, then this will become a plus, this become a minus. Okay, nothing changed. Okay, okay, so minus m naught g. Okay, derivative of the L with respect to L is 1. Sine phi. Sine phi is constant. Mg sine phi is constant. Derivative of delta L with respect to L, that will be 1. So because of this minus, there will be minus. Okay. Okay. Plus Ct. C is constant. Okay. Now the derivative of L dot. R k is L. The derivative with respect to L dot. Phi, derivative of phi with respect to L dot. Derivative of L dot with respect to L dot, that will be a 1. 1. Derivative of L dot with respect to L dot, that will be 1. And derivative of 1 with respect to derivative of 1 with respect to time, that will be a 0. So this term become a 0. Okay. And when we take with the derivative with the L, no L is involved here, this is 0. Okay. Clear?
Yes, sir.
Okay. So this total term will be a 0. So when we multiply 0 with this 0, that will become a 0. So, and when we take the derivative with respect to L dot, okay, phi L dot, that will be 1. When we multiply C dot, derivative of L dot with respect to L dot, that will be 1. That is equal to 0. Or you may write as C dot T is M naught G sine phi. This is one equation. Okay. Okay. Now, if we take the now we consider the now we must consider R2 equal to R2 is theta. Okay. So R2 is theta. R1 was this. R2 is theta. So when we take the with respect to theta, here theta dot is involved because theta dot. This term will be 0. 1/2 M naught is constant. 2, firstly power will be changed. 2 R theta dot, power will be shift. Derivative of theta dot with respect to theta dot, that will be 2 R theta dot. Okay. 2 R theta dot. Okay. And when we take the derivative, because we are taking with respect to theta dot, derivative of this term, R theta dot with respect to theta dot. R is constant. R theta dot with respect to theta dot, that will be equal to 1. Okay. So where is Justice? Thank you. So this R will be multiplied with this will become a R square. Because it is simple, R is radius, and that is also not changing with respect to time. Yes, this R is a scalar. So when we apply the dot here, this become a, when we apply this derivative, this will become a, R is constant, 2 will be cancelled, and this become a R double dot. R is constant, theta double dot. Okay. So R square theta double dot. Yes? Product formula will be not applied because R square is constant. Okay? Plus one by two is also cancelled. Okay? Plus theta dot theta with respect to theta dot, where is constraint? This is constraint. Okay? No, this is constraint. Okay? This is zero negative term. Okay, so this sum will be replaced with the minus Ct d by dt. Okay, minus R is constant. Derivative of theta dot with respect to theta dot, that will be 1. Okay, but when we take the derivative of R, okay, because theta dot derivative theta dot is the 1, and derivative of R with respect to t, that is 0. So this term will become a 0. So ये 0 हो गई, ठीक है? So ये finish हो गई. Okay. Now it's here. Derivative of phi with respect to, then again minus, okay, and derivative of with respect to theta, and no theta is involved. This is also 0. Now plus c dot theta with respect to theta dot, phi with respect to theta dot, because R2 is theta, theta dot. Okay. B by no, only the derivative. Okay. Theta dot R is constant. Okay. Minus this plus will be due to this minus, that will become a minus because here is plus. So due to minus, this will be a minus. Derivative of theta dot with respect to theta dot, that will be a 1. So 1, and this will be a 0. Okay, and this implies that this is equation 2. Okay. Yes, m r theta dot is equal to CTR. Okay. Dot theta dot is equal to 1. Theta dot is 1 minus r yes, that is minus r. Okay, this is equation 2. Here is double dot. Here is double dot. Okay, you know that. Oh, sorry. So and from constraint equation, what from constraint equation, what is the value was L dot was R theta dot. That was the constraint. Okay. And when we take the time derivative, because we are required the R is constant, that will be theta double dot. This is equation 3. Okay. This was a C dot. Yes. Yes. Okay. That's all. Okay. And so now you have a 3 equation. Okay. Okay. No. This all may be cancelled with this. Okay. You may write in this way. Yes. Okay. Okay, because theta is the angle of rotation. We don't know, we are not interested to find the theta because theta is changing with the time. So theta must not be, that is unknown variable and we unrequired variable. So we must remove this theta. Okay. So from this equation 3, we may write theta double dot is equal to L double dot over R. Yes. Okay, and if we put it into the in equation, put in equation 2, okay? Then C dot T will become theta R will be cancelled with the R. That will become M naught. M naught L double dot. Okay. Yes. R will be cancelled with this R. Okay. And this become this. Yes. And we put this value in equation 1. Okay. But why we will put, okay, this will be M naught we may find exactly so if we put it in equation 1, that will become M naught L double dot put in equation 1 M naught mg sine phi. Okay, and M naught will be cancelled with this, so double L dot will be g sine phi. Okay. So you can find the C dot L double dot, okay, the velocity, okay, this is the theta was unknown, you have removed it, okay, you know that what is the radius of the ball, okay, so here you know the mass of the ball, and phi is the angle of inclined plane. Okay. If you want to remove this phi, you may also remove from M naught g sine phi. You may also find the relation for the phi. Phi will be sine inverse of L double dot over g, and you may find everything you are interested. Okay. So this is the way to find the to solve to discuss this system with constraint. Okay. For mass moving, mass rolling on the inclined plane. Okay. Yes. I think. Okay. Yes. Yes. ये या ये R2 is theta. When this will be theta dot. So you take the derivative with respect to theta dot. Okay. 2 will be 2 will cancel and 2 are theta dot. Okay. Actually, this was partial L over partial theta dot over d by dt. That one. Okay. When you take the derivative This will be 2 cancel, okay, m naught d by dt, power will be shift, so it will become r theta dot, and you take that derivative with respect to theta. When you take again the derivative of this will be r d theta over, got it, not got it. नहीं, मेरा ख्याल है नहीं पता चला, क्योंकि अगर दोबारा पूछ रहे हो तो इसका मतलब पता नहीं चला होगा. d by d theta dot ये ले रहे हो आप इसके ऊपर, r is constant, it will come out. See, so m naught d by dt r square theta dot, derivative of theta dot with respect to theta dot, that will be equal to 1. Okay, so this will be become m naught, r square is constant, theta double dot, r square theta. Okay, so in this way, okay, clear? So okay,
Yes.
so this this derivative of phi with respect to theta dot, that will be minus the minus, this is a phi. Okay, when you take derivative of phi, with respect to theta dot, this is 0, r is constant, derivative of phi dot with respect to phi dot, that is 1, that was the cm 1. Clear, Ahmed? Clear? So this will be it. Okay, everything must be clear, I think. Okay, got it? So this is required, and this is a complete solution of this circle. Okay, so